Okay, what we have here is geotrig lesson outline 5. We're going to start part A, and part A is exponents and radicals. Again, I already kind of talked to you guys about this, but we are going to have to start to do problems that are pretty complex already. They're going to take all my 7 exponent rules, throw them all into one problem, and say, here you go. We're not there yet, so let's actually take a step back and say, hey, do you remember your exponent rules? I'm, again, not really caught up on definitions and names, as in, can you recite, what does it mean for this or that? But I am going to hold you accountable for, if we have to use it, can you apply it correctly? So the names, not that big of a deal. So the first one, let's do a product of powers, which means, can you do x to the n times x to the m? That is a power of product of powers, right? That's the name. Who cares, necessarily? It's not all that important, but do you remember what to do here? What do we do? Alex?
Multiply the exponents together?
Multiply your exponents together? No.
Add them.
Add them, correct. So, remember, if the bases are the same, you can keep the base, but then add the exponents. Next one, if we can multiply exponents, why can't we divide them? What do you think we do when we divide bases that are the same? What happens to their exponents? Subtract. So, therefore, to be x to the n minus m, right? Another one. That's the quotient of powers. What about a power on a product? Power of a product. We got 2 things inside a parentheses with an exponent on the outside. What's that? What do we do?
We distribute the exponent to both of the variables.
Yeah. We take the exponent and bring it in. We act like we're distributing here. It's not really distributing, but we're going to act like it is. So it's a to the n times b to the n. You guys remember these? We also can have a power on a quotient. So a divided by b with a power of n. I don't distribute to just the top, I distribute to the
Bottom.
top and bottom. So I get a to the n over b to the n. What's another one? Anybody recall any others? It says there's 3 more. Anything to the 0 power is 1. The 0 exponent rule. We like that one. It's amazing how many people get mixed up and say that it's 0. We got 2 more. Trying to think. Yep, Melanie.
Negative exponents?
Negative exponents. We don't like those, do we? So x to the negative n. Where does it go? Yep, to the basement. And becomes a positive exponent. I'm going to add to this. What happens if I'm in the bottom with a negative exponent of m? Let's see.
Switch it.
Switch it where?
Next to the top.
It goes to the top and becomes positive exponent. Right? It can be over 1 if you want. We don't need to write it over 1. So, negative exponents on top, bring them to the bottom, become positive exponents. Remember, the only thing that gets moved is the thing with the negative exponent. If there's something in front of it or behind it, they don't move unless they also have negative exponents. And there's one more.
any number with an exponent of 1 is itself.
Okay, we don't usually generally have that as an exponent rule, but I would agree a to the first power is a, right? Or x to the first is still x. So any number to the first power is itself. That's like kind of like an identity, right? Exponent identity. There's still one more out there. How about something with an exponent, like x to the n, that is raised to another exponent? So we call that power of a power of a power. And power of a power, you? What? Multiply. So x to the n times m. Those are your 7 exponent rules. You guys should know how to use them to combine. You also should know how to use those to potentially split up your numbers. Up next is we also have that idea of quotients as exponents. Fractions, exponents, right? We have here a number x to the power of m over n. Remember that anytime you have a rational exponent, you can change it to radical form. Exponential form, radical form. Exponential form, radical form. I know you guys can reverse that. You can say radical form, exponential form. Okay? So make sure you guys know that. And do you guys see that there's certain placement for the top of the fraction and the bottom of that fraction? Look at your square root or your radical. It's not really always a square root. The n is that number that's tucked inside the little area in front, right? That is on the denominator. The power that's inside on x is the numerator. There's one thing I don't have on here. There's one more version of this. We also could write this as the nth root of x and all of that to the m power. I don't know why they don't have both of those on there, but we can use both of these at our advantage. One is usually has more advantage than the other. I actually prefer the second version, the one I just wrote up here. Because to take the nth root of something, like the cubed root of 8, what's the cubed root of 8? You guys remember? 2. It is 2. Because cubed root means what number times itself 3 times is 8. 2, because 2, 4, 8. Who do we appreciate? Okay. And then I can take that to a power. So also don't forget that if I have the square root of 4 times the square root of 4 again, what do you get? What's the square root of 4 times the square root of 4? Well, do you guys remember the property that if I take a square root times another square root, I can multiply the numbers inside? So isn't that just the square root of 16? But wait a minute, what's the square root of 16?
4.
So remember, if you multiply square root to itself, you basically are canceling the square root, leaving you with whatever's inside that was multiplied to itself. A square root actually means what times itself is 4. Well, in this case, that's 2, and 2, so 2 times 2 is 4. Multiple ways to get this answer. But do you guys realize from up above that a square root of 4 is the exact same thing as 4 to the 1/2 power? Do you guys agree that this is the square root? Now here's the thing. You guys remember, there's no number inside here. What do we call this thing? Square root. Square is 2, right? So therefore, there's actually an invisible 2. It's assumed. It's implied. There's a 2 inside there. That 2 is what goes on the bottom of your fraction here. But wait a minute. That's 4 to the 1/2 power times 4 to the 1/2 power. What do you do? The bases are the same. You're multiplying. That means you can do what to those exponents? Add them. So you're saying that this becomes 4 to the 1/2 plus 1/2. And a half plus a half is 1 whole 1, which is 4 to the first. And according to what Alex said earlier, anything to the first power is that thing, which is 4. That whole entire line just repeated itself a couple different ways to get to the same exact answer. Is that cool or what? So let's do this problem here. I want you to simplify. Notice they didn't say solve. You can't solve something that doesn't have a what? An equal sign. Doesn't have an equal sign, you can't solve it. Simplify means there's got to be an easier way, maybe not easier way, maybe just a better way of representing the exact same thing. So what we have here is the square root of x cubed y times the 4th root of xy cubed. It's got x's, it's got y's. Wouldn't you think it'd be easier if I could put all the x's together and all the y's together? That's what we're going to do. Using what we had on the board before, that I can change radicals to exponents and exponents to radicals at times. Can we change everything just to standard radical form? Not radical, exponent form, sorry. Everything to exponents. Give me fractions. I know it's not what we like to hear. It's okay. So, square root. Square root is like what fraction? What power? What power is associated with square root? What's the number tucked into there that I said wasn't really there? 2. So it's a half, right? So would you guys agree that x to the 3rd power y, which is all inside there, has a power of 1/2? I may have to shrink this down to make it work, but we will. The other one's a 4 inside there. That's a 4th root. So I'm going to take that, xy cubed, and put what power on it? 1/4. Now what can I do now that I have all exponents? That's a power on a product, isn't it, right here? I've got a parentheses with some stuff in it that has an exponent on it. And I got this one has an exponent on it as well. Bring the exponent in. Look at your x. X has a power already, doesn't it? So what should I do with those powers? Multiply. So this would be x to the 3/2 power. Y to the what power? 1/2. Bringing the next one in. So 1/4, that means it becomes x to the 1/4. Y to the 3/4. So all I did was, first of all, switch it to exponents. 2, I distributed the exponent in as a power. Now I have x's and y's by themselves. Wouldn't you think it'd be really nice just to put them together? So put this guy and that guy together. Aren't these all multiplied? And if I multiply numbers, can I multiply them in any order? So in that case, I'm going to take the x's together and the y's together. So if I do that, this becomes x to the, what's the first exponent? 3/2 plus the next exponent, 1/4. I'm going to try writing a little bit larger here. Y to the 1/2 plus 3/4. All I'm doing is taking the exponents, right? 3/2, 1/4, 1/2, 3/4. Now the last step, I think there's still one more step to do. I actually could put those together. To put fractions together by adding or subtracting, they need to have
A common denominator.
common denominator. Oh boy. Okay, so I'm going to change colors. We'll go to blue here. What do I need to do? What's the rule here? What do I have to do to get a common denominator? I've got a 2 and a 4. On both of them, actually. So what's the common denominator for both sets?
4.
Yes, it's 4. How do I make that a 4 on the 3/2?
Multiply the 2
Multiply the 2
by 2.
by 2, but what I do to the bottom, I have to do to the top. So I'm going to go here and say, oops, not that. Times the bottom by 2. You can kind of see that on the screen. But what I do to the bottom, I have to do to the top. So you're saying that I'm actually going to get x to the 6/4 plus 1/4. I could do that math, right? Okay. And then y is, oh wait, I got to multiply that 2 by 2 as well. And the top by 2. So that becomes y to the 2/4 plus 3/4. So moving over here, x to the 6 plus 1, 7/4, y to the 5/4. Done. Now, I could ask you to put that back into radical form as well, right? But is everybody with me getting this into exponent form and I can combine them up? What would this look like in radical form? Ready?
So it'd be 4 and then the
Inside the square root thing, yeah, the root radical.
radical x7,
x7.
and then 4 inside the square root thingy, and then y to
Y to the 5th. Hey, wait a minute. Isn't that the same root? Could I not actually combine them to be in the same house, we'll say? The 4th root of x to the 7, y to the 5th. So we could have done that instead. So each one of those is technically a correct answer. I'm okay with this being in exponents. This one, I think, I would hope you guys would recognize that since they're both the 4th root and you're multiplying the same things, bring them into the same house. Okay? Okay, next problem. That is a to the x over 2. It's a little fuzzy on the screen. Parentheses, y to the 2 minus x power. End your parentheses with a 1/2 power. Oh boy. Over a to the 3x, y to the negative 2x. That's x over 2. 2 minus x as a power to the 1/2 power. A to the 3x, y to the negative 2x. I want you guys to try this. This one's not too bad. Apply your rules, exponent rules. I want you to try it on your own on your paper right now. We'll come together and fix this. In the video, it's going to seem like seconds. Okay. Someone give me an idea for their first step. What do they want to try to do?
he said move the negative exponent.
Okay, move the negative exponent to the top. That means I got to rewrite everything. So a equals a to the x over 2, y to the 2 minus x to the 1/2, y to the what? 2x now on top. All of that is over a to the 3x. Next, what we're going to do. Here's the wonderful thing, when someone gives us an idea in class and we run with it, now everybody's got to change some of their plans and go with this one. And that's A-OK. How about the A's? Bo, what do you want to do?
Subtract the exponents.
Yeah, subtract the exponents, guys. You got an A on top, you got an A on the bottom. You're dividing those dividing the bases, so therefore you subtract your exponents, right? So it should become A to the x over 2 minus 3x, right? Okay, all of that goes on top. Actually, everything's on top now, right? So I don't need the extra line. Y to the, whoops, 2 minus x to 1/2 power y to the 2x. Anything else? Well, first of all, with those a's, I probably should get a common denominator, right? So can we do that right away? What's the common denominator? What's underneath the 3x? What's really underneath there? 1. So to get that to be a 2, I need to multiply it by 2, but what I do to the bottom, I do to the... So that makes that a negative... What? A negative 6x? Would you guys be okay with me just writing negative 6x above it? Or just minus, we know it's going to be a minus 6x, so what's x minus 6x? Negative 5x over 2. That's cool. We fixed that. We're done with the a's. We're done. Well, not necessarily, right? Because it's negative. We'll fix that later. What should I do with that 1/2? I've got to distribute it. Why? It's not just multiplied, it's distributed. It's because the exponent itself has multiple parts, right? That exponent itself is a binomial, so therefore you have to distribute. What's a 1/2 times 2? What's a 1/2 times 2? All the way in. 1? Minus? X over 2. And then y 2x. We can multiply the y's together, right? The bases. But what does that mean to our exponents? Add them. So I'm going to put these two together now. Okay, so am I going to do anything with the a right now? Can we just leave it? We'll take care of it at the end. So that's a equal a to the negative 5/2 x. And then this becomes y to the 1 minus x over 2 plus 2x. Oh man. Everybody's got different denominators there. Well, maybe not everybody's got different ones. But we got a couple different things going on, yeah? So it means I got to put that together. The 1's really over 1. The 2x is over 1. The common denominator between those three would be 2. So I got to multiply by 2 over 2 and 2 over 2, yeah? Well, 2 times 1 is? So we get y to the 2 over 2 minus x over 2 plus 2 times 2x? 4x over 2. Does everybody see the common denominators now? So all of it can be written over 2. Probably should have wrote this way over here. But I won't. Okay. Negative 5/2 x y to the all over 2. What does the top become? What can we do at the top? Could we gather up like terms? What's the like terms? Negative x and 4x, which makes a And the 2 goes along for the ride. I would say we're almost done. The last thing you need to do with this problem is send the a to the basement. So you get y to the 3x plus 2 all over 2 over a to the 5x over 2. Notice that the negative disappeared, yeah? Done. So your homework is page 47, 1789. Have a great day.